going, you go on round cruise. Two travel agents are $100, so it's going to cost the same amount no matter which package you choose. The agents have unusual finance offers, and these are unusual. With each agent, you are charged interest over time, but rather than making monthly payments, you're expected to pay the cruise off, principal plus interest, in a single lump sum payment at a date of your choosing. You will need at least a year after saving money to pop. We made you have it paying back like you would. It's too complicated of math for us to do for this class. So we're going to make up a kind of weird scenario. We kind of compare this to the mob in class. So agent A is 12% interest per year. Okay. Agent B, it's 1% interest per month. Okay. So we need to decide as a group which agent's plan is better for your unique needs. So we're not going to be able to do the second part, but I do kind of want to just go over this. So hopefully what I would really like you to do is sort of explore this on your own. Come up with your own thoughts, do some math maybe. And then once you've done that, then I want you to hit play and see what I have to say about it. So hopefully you've had a chance to look at this. So I actually am going to just put up the work we did in class today. So in class we talked about this and got a little off topic and then talked about it some more. But first of all, what we did is we just figured out, okay, if we went with agent A in a year, how much would it, because we know it's got to be at least a year, so let's figure a year. And by the way, our hypothesis was that agent B would cost more because you're compounding that interest every month. You have to pay interest on that interest. So, what we did is we put 0.12 for 12% times 20,000 plus the original 20,000, and we ended up with 22,400. I have an extra zero on here. Okay, so that's our number for agent A for 1 year. Well, agent B is going to be a little bit more complicated to figure out. So what we had to do for agent B is we had to calculate the, I'm going to cover this because it's distracting right now. We'll talk about it in a second. We had to calculate the interest every month. So for the first month, you would do 20,000 plus 20,000 times 0.01, which was 20,200. But now you have to take this number and put it back in times 0.01 to get the next month, and then again for the next month. Now what I ended up doing, that you can start doing to save you some work, is I was like, well, isn't this the same thing as doing this number times 1.01? Then I don't have to put it in so many times, and it actually is the same thing. So then what I do is I just can start with 20,606.02 times 1.01, and that gives me that number, 20,812.08. And then I can just keep multiplying 1.01. And once you're doing this, you can just keep hitting enter until you get all the way up to, that's 9, 10, 11, 12 months, which puts me at $22,563.50. So, I'm going to erase this scratch work because it's a little confusing. We'll redo it here in a second so you can see what we talked about. But the point is that down here at year 12, or at month 12, which would be the end of the first year, we are definitely exceeding the other company. So it definitely looks like after a year, you're going to pay more with agent B. And I would imagine that the further you go, the worse it's going to be as far as how much more agent B is going to cost. So then we kind of went, well, do we really have to do all that math in order to find these numbers? Like, isn't there a faster way? And the answer is, of course there is. For this first one, if you wanted to just put the years in, you would say your initial amount times your interest is 12%, so it's 1.12 to the t for years, if t is years. Okay, not so bad. But what about this one? Well, seems pretty easy. Let's use M for months. You do 20,000 times 1.01 M. Well, is we can't compare that equation or expression with this one, because here T is standing for years and M is standing for months. So now we can relate back to task 9 and we can think, well, what if I want this to be in years? This is already my monthly interest rate. What would I do to say, okay, let's talk about this as years? Well, this is my monthly interest rate. How many times do I do that in a year? 12 times. So I would just change that M to 12T. So it would be 20,000 times 1.01 to the 12T. And now I can kind of compare my functions, but again, they just don't look the same. And it's still not proving this idea that the interest is higher with agent B. So then what I would do, and this is important because you're going to have to be able to do this on Delta Math, is I want to know my annual percentage rate for this situation. This one I already know my annual percentage rate is 12%. But since I'm compounding this monthly, that's essentially what we're doing. I would need to do 1.01 to the power of 12 to figure out what my annual percentage rate is. So I'm going to do 1.01 to the 12 power, like that, and I get 1.126825. I'm just going to stop at 8 though, which hopefully you can see that now we can kind of compare these two functions, because now this would be, so this is A, B would equal 20,000 times 1.1268 to the T power. So now, if we're comparing straight across, you can see that the annual percentage rate for option B is higher. Not by a lot, but it would add up as we move forward. So, hopefully that sort of helps you understand why agent B is more expensive. You're compounding 1% more each month. And hopefully you can see why we're multiplying 1% to the 12th power, because you're doing 1% times 1% times 1% times 1% 12 times. And so then that actually is still increases, but it's 12.68%, not 12%. So, what I would like you guys to work on now is your Delta Math Lesson 3, and you're going to be writing equations like this, and you're going to have to start by putting it in this sort of format, and then you're going to have to translate it to this format so you can find your actual annual percentage rate. So go get to work on that. Make sure you watch the videos if you get stuck, or click show example, and good luck.